Welcome to another session of mathematics, folks. It is still Euclidean geometry, grade 11, circles. I'm now doing the second theorem that deals with cyclic quadrilateral. And the theorem states that the exterior angle of a cyclic quadrilateral, I'll just write cyclic quadrilateral is equal to the interior opposite angle. As a reason, you now just say exterior angle of a cyclic quad. You don't have to write it in full, but now understanding it is very important. Now, remember that for it to be a cyclic quad, all vertices must be on the circumference of a circle. How are you going to prove this theorem? You shall be given circle with center O and cyclic quadrilateral A, B, C, D with CD produced to E. And now you are required to prove that angle B, which is this angle, is equals to that angle, which is the exterior opposite angle. Now, the proof to this theorem, this is a beautiful one now because I just use my other basic knowledge. The proof to it, I can go there and say, this is angle C1 and this is angle C2 because I've got two angles C's. Now, I would start by saying angle C1 plus angle C2 is equals to 180 degrees. How do I know that? These are adjacent supplementary angles. Please don't say angles on a straight line. They are adjacent supplementary angles. Now, what else do I know? Remember, I want angle B now. Whatever that I'm bringing after this, it must have angle B. That is why I'm going to say angle B plus angle C1, they add up to 180 degrees. How do I know this? These two angles are opposite angles of a cyclic quadrilateral. Remember, the theorem states that opposite angles of a cyclic quadrilateral are supplementary. Now, look at these two mathematical statements. Remember, geometry is all about logical reasoning. Now, if you look at these, I've got 180 here and 180 there. What does this mean now? It means that if this is 180 and this is 180, therefore I can correctly say that LC1 plus LC2 is exactly the same as LB plus angle C1. What is my reason for this? Both of them are equals to 180 degrees. Now, when you look at this, if I can take angle C1 to this side, it would be negative. Therefore, this and that will cancel. Now, I can see that I'm now left with angle C2, which is equals to angle B. Let's go to the required to prove statement. They said we should prove that angle B, which is this angle, is exactly the same as angle ACE. Who is angle ACE? Angle ACE. We are talking about angle C2. We have proved the theorem. I can therefore say angle ACE is equals to angle B. I have proved the theorem. Now, from proving the theorem, it satisfies that it is true. Certifying that it is true, it means I can apply the theorem wherever I see it. Thank you very much, folks. Enjoy this one. Signing off. Ding ding.